Hello everyone. We are to prove the vertical angles theorem, which states that the vertical angles are congruent. To prove this given theorem, let us consider the situation here, where line AB intersects line PQ at point M. And here we are to show that the vertical angles formed, angle AMQ, is congruent to angle BMP. If we could show that these two vertical angles, are congruent, then we might say that the theorem has already been proven. To do this, we are to use the two-column proof, where we list here statements, and for the other column would be corresponding reasons that will tell us that each statement placed here are considered to be true and correct. We are going to arrange our statements and reasons in such a way that we are going to yield with this intended output. To start, we are going to use the given situation and place here as our first statement. So let us write it here. Number 1, line AB intersects line PQ at point M. The corresponding reason is that this is the given situation. Out from this first statement, we need to come up statements and corresponding reasons that will yield to the intended outcome. And since we are dealing with congruent angles, we need to show that the second statement will involve angles. And for this situation, we can actually declare that angle AMQ, this angle here, and the other angle, angle QMB, are forming a linear pair. As you can see, where line AB intersects line PQ at point M, we have made here four different angles, and two of which are again angles AMQ and angles QMB, and they are actually forming a linear pair. The reason for this is simply the definition of a linear pair. Aside from this, we could also create another statement which has the same reason. That statement is a statement that will involve the second angle that we would like to show later. And hence, we have this angle, angle QMB, and angle BMP are also forming a linear pair. With the same reason of the definition of a linear pair. It's very important for us to make clear of our reason, since after we have established this statement, we are going to get the relationships of the angles that are forming a linear pair. In this case, the third statement, we could say that angle AMQ and angle QMB are supplementary. This actually brought us with the linear pair postulate, which tells us that angles forming a linear pair are considered to be supplementary. Since the previous second statement also involves angle QMB and angle BMP, let us also write it here. We have angle QMB and angle BMP are supplementary. With the same reason, the linear pair postulate. After this, we could now get into the specific relationship of the measurements of the angles. Our fourth statement here is that the measurement of angle AMQ plus the measurement of angle QMB is equal to 180 degrees. This is actually with the definition of supplementary angles. Same as true with the measurement of angle QMB plus the measurement of angle BMP is equal to 180 degrees. Same reason, definition of supplementary angles. As you can see, we are now getting closer to our intended outcome since the concept of congruence would involve the concept of measurement of angles. Out from here, we could actually create a situation where the left-hand side of this first equation is equal to the left-hand side of the second equation. And why is that? Since both of the left-hand side of the two equations be equal to 180 degrees. Hence, we could write it this way. The measurement of angle AMQ plus the measurement of angle QMB is equal to the measurement of angle QMB plus the measurement of angle BMP. Again, the left-hand side of the first equation is now equal to the left-hand side of the second equation. This actually uses the transitive property. Or other might argue, you could also use substitution property. Out from this, we could now apply or involve other mathematical procedures such as subtracting both sides with the measurement of angle QMB. Since these two are just the same, removing one on one side of the equation and doing it on the other side as well will not change the equation. Hence, we will have this statement. Number 6, the measurement of angle AMQ is equal to the measurement of angle BM. We have here the subtraction property. Of equality, both for number 5 and number 6. Look at the statement here and the statement we would like to prove earlier. We need to show that angle AMQ is congruent to angle BMP, and we are now one step closer to that. Because when we say that two angles have the same measurement, we could claim that angle AMQ is congruent to angle BMP. And the reason for that is the definition of congruent angles, or the definition of angles with the same measurement. We have achieved this given statement. Therefore, we have proven that the angle AMQ is congruent to angle BMP in this given situation. And hence, we have shown that the vertical angles are congruent. You could also use this given proof if you would like also to show that angle QMB is congruent to angle PMA. This is the proof for the vertical angles theorem, which tells us that vertical angles are congruent.